Alright guys, welcome to chapter 9. In this chapter we're going to start talking about functions. We've been talking about equations, now we're going to work with functions. So our definition here, a function is a relation where every input or x value, which is our domain, has exactly one output or y value, which is our range. So a couple vocab words here. If you want to go ahead and highlight them. We have our domain is our x value. Your range is your y value. And then the whole thing, a function is a relation where every input has exactly one output. So what does that mean? We have a couple different things that we can look at. Look at our first example here where we have tables or ordered pairs. So each of these x-y pairs creates an ordered pair. So what we want to look for is that each of our x values only has one y value. So basically you're looking for are any x values repeating. Well, if I look through, I see I have a 4, 7, 6, 3, 5, and 2. So none of my x values repeated, so that is going to be a function. If we look at our second example here, I have a 1, 6, 3, then I see I have another 1. So I have a 1, 7, and I have a 1, 8. So this is not a function because the x value of 1 has two y values. So it's not a function because the x value of 1 has two y values. Okay, another way we can tell is if we are looking at a graph. We want to do what is called the vertical line test. So vertical, think of your pencil. If you can drag any kind of straight line, in this case a pencil, across the entire graph, and it never hits more than one point at once, then it passes. So the first graph here is a function. If we take our pencil over to our second graph here, so far so good, then all of a sudden we hit right here, and we see it would hit both of those points at the same time. Same thing here, it would hit both of those points, and both of those points. So my x value of 2 has a y value of 1 and 3, so this is not a function. Again, using the vertical line test, we're looking to see if a vertical line would hit more than one point at any given time. Okay, and then the last thing we want to look at is mapping. You're basically just looking at your arrows. So your 2 is mapped to just your 1, your 4 is mapped to just your 3, 5 is mapped just to 4, and 9 is mapped just to 7. So none of my domain values repeat. So this is a function. And over here, we see 2 is being mapped to the 1 and the 3. So again, not a function. Okay, so now that we've looked at the definition of function and some different representations, we're going to start using them. So a function that is written as an equation can also be written in a form called function notation. So last chapter you would have seen y equals 2x plus 3. Normal equation. This time we are going to replace our y with our f of x. So f of x equals 2x plus 3. Notice our sticky note here. F of 4 means to find the value of the function when x equals 4. So whatever is inside your parentheses, that is your x value. So our first example here, if f of x equals 14 plus 3x, find each function notation. We have f of 4. So I'm going to start by bringing the function down. So f of x equals 14 plus 3x. Now I want to find f of 4. Now notice x is replaced with a 4. So on the other side, we're going to substitute in a 4 each time that we see an x. So we had x before, now we have a 4, and and a 4. So your function notation is just telling you which, what value to substitute in for your x. Okay, now we solve just like before. So f of 4 equals 14 plus 12. And finally, f of 4 equals 26. There's our final answer. Now notice, the f of 4 came down each time. That is part of your answer. You cannot leave off that function notation. Okay, so same idea. F of x equals 14 plus 3x. This time I want to find f of negative 7. So we substitute in a negative 7 for our x. And then simplify down just like before. So 14 minus 21. And f of negative 7 equals negative 7. Now also notice nothing is happening over here. We just bring it down each time. You don't have to solve anything on the left side of your function notation. Okay, so there's some examples solving. And last up, work with some word problems. Mariah spent $22.50 downloading songs to her digital music player from an online music store for 90 cents each. Part A, identify the independent and dependent variables. Then write a function to represent the total cost of any number of songs. So our independent that would be your x value. That's what's determining the rest of it. So your independent, again, that's your x value. In this case would be the number of songs she downloads. So then our dependent, which would be your y. So what is the number of songs affecting? It is affecting the cost. So if we let x be the number of songs, so our independent variable, then f of x, since we want function notation, well, what are we doing? 90 cents per song, so 0.90x. There's your function. F of x equals 0.90x. In part B, use the function to determine the number of songs that Mariah downloaded. We're going to start by bringing our function notation down. Now in this case, we already know her cost. We don't know the number of songs. Her cost, if we look back up here, was the y, which since we're doing function notation is now our f of x. So we're going to substitute the 2250 on the left side. So 2250 equals 0.90x. And then just like last chapter, they're being multiplied, so divide on both sides. And we get 25 equals x. So Mariah can download 25 songs. All right, there is section 1.